Hey, this is Workbook 26, which is a proof of the Pythagorean theorem. There are many proofs of the Pythagorean theorem. And in fact, cool fact, one of the US presidents came up with his own proof of the Pythagorean theorem. It was James Garfield. Can you imagine how awesome that would be to have a president that loves math so much? To me, it would mean a lot. Okay, so the Pythagorean theorem is the theorem that a squared plus b squared equals c squared. And this workbook is a proof using similar triangles. So these are what you have to remember. And what they said, instead of just a squared plus b squared equals c squared, they said the segments. So technically where the a and the a squared would come from is a is the side directly opposite of side A, of angle A. So just like we've been talking about, the opposite means the endpoints don't touch the angle itself. So BC would be A squared plus B squared. And again, this goes to the one that's directly across from angle B, meaning it doesn't touch B. So that's segment AC squared equals AB, which is the C squared. So C squared is always the hypotenuse in that theorem. So they're talking about how they are, so like we have that this is a right triangle and we're supposed to prove it. So they go through, and then this is why I'm going through this, because a lot of this stuff is needed. So you'll have to know something called an altitude. So if we were to turn this triangle around, so let me just see if I can draw it here. If we were to turn this around, and so then C was on top right here, it'd be about right there. And then A would be like there-ish. Turn it around so it was flipped like this. Then the line that they drew right there, that CD would be right here. And you would see that it's like the height of the triangle when it's like that. So that's what the altitude is. It's the distance from the right angle of the original triangle to this opposite side. So that's kind of talking about the height of the triangle. But then with that, then you have basically three triangles. You have the large triangle that we started with, triangle ABC. Then you have this medium triangle. And if I'm going to look at the original thing here. So this medium triangle right here, and then a small triangle right there. So they look at those a lot. So then we said that triangle ACD is similar to triangle ABC because they're both right. So that's the proof of it. And so they started out by saying that the right angles are similar because they're both right. They're congruent because they're both right angles. Both of the triangles share angle A, which means that they are similar. Does that make sense? And then you can also, so that was doing the small one, ACD to ABC. So that was doing the small one to the large one. And then this is doing the medium one to the large one. Same thing, they're both similar. And then they say, since those two are similar, oops, I gotta take this pencil off. Since they're similar, then we have these proportions. So it's all about proportions basically. And so let me just walk you through this. So AC, so that's the long side of, there's two things with this. AC is the long side of the small triangle, or you could say it's the short side of the big triangle. But AC is to AB, so that would mean short side of the big one to hypotenuse of the big one is to AD, that's the short side of the small one, to AC, and that's the long side of the small one. So hypotenuse, the short side and the short leg and the hypotenuse, short leg and hypotenuse. And then they did the same thing with these. So they did hypotenuse. This is long leg. And then they said hypotenuse. So long leg of the medium one to hypotenuse. And then they already said that those sides are the same. BC is the same thing as CB. And so they just rewrote the second one. And then they have all sorts of confusing looking things if you just look at this. But basically what they're doing is they're going through and using proportions and coming down with what AC squared is made up of and what BC squared is made up of. Then they add them together. And then you can take out the AB, you get those two things added together, which AD plus BD added together is AB. And so then that has to be AB squared. So it's a long proof. So I need to refresh my browser. I haven't been in for that long, but whatever. We'll come in again. Okay, so coming down to the actual proof, there's the answer key, and I can't see it because I'm not in it as a student. So I will pause here. Okay, here we go. So we have used the figures and the information to complete steps 5 through 8 in the proof. So we're given that ABC, that's the big triangle, is similar to the medium triangle, so CDB. And we know that AC squared is equal to AB times AD. Okay, and we're supposed to prove that the Pythagorean theorem. So we have this, they're given. We talked about this stuff. So this is where they did a bunch of proportions, figured out this part, and then BD plus AD. So let's look at the picture. We have BD plus AD. Well, that makes up, that's angle addition. That's segment addition. Let's see, but how we got from here to here, that was to just like factor, because that was a common factor between those two. So AB was in that one and in that one. And then this is just simply a statement. This is segment addition postulate, because we know that those two add up to AB. And now this was just substitution, because we substituted this thing, AB, in for that thing. That was substitution. And then AB times AB is just multiplication, that they are squared. So that was not too bad. Then the next lesson is lesson 27. I'll do a separate video for that. Just kidding. I meant to say 26.2. So then we have to use the Pythagorean theorem. So it's just using a squared plus b squared equals c squared. And they have a pretty good video that explains that. I'm just going to go straight to the homework about it, because I can remember this from doing from previous years of math if I were a student. So I would know. In fact, let me just share two little things that will help make this easier for you if you are kind of newish to the Pythagorean theorem or you forgot some things. So let me show you some things that you could call them tricks. They're just still good math that we did in advance. So if you are going to be using the Pythagorean theorem to find either a missing hypotenuse or a missing leg, then this is what it does. And I'm calling this the math preloaded, because it's not like it's not true. It's just preloaded. Or it's a shortcut, but you can also call it math preloaded. So there's reasons why we do all this stuff. But if you want to find the hypotenuse and you know the two legs, so remember the ones that are attached to the right angle are the legs. If you know the legs and you need to find the hypotenuse, then you just find the square root of the sum of their squares. So you do the square root of leg squared plus leg squared. If you are supposed to find a leg, if you're supposed to find one of the leg, the sides that's attached to the right angle, then you do the hypotenuse squared minus, and this is the big thing with this one, minus the legs squared. So if it's just the legs, you add them. If it's a leg, if you're trying to find the hypotenuse, you add them, add the legs. If you're trying to find a leg, you do hypotenuse squared minus the leg squared. So this makes life a lot easier with this stuff. So coming back to the problem that we had, right here, we have and I can recognize that the hypotenuse is because it's directly across from the right angle. So that's the hypotenuse squared. I'm given a leg, so I want to find the other leg. So I'm going to use the one that I had on the right, and I will come back to that in a second. So I'm going to write down what I know. I know that the hypotenuse is equal to 20, and one of the legs is equal to 12. So coming back to my work that I was doing before, I know the hypotenuse is 20 and the leg is 12. So I'm going to do this one. I'm going to do the square root of 20 squared minus 12 squared. And I could do this in a calculator. So we do 20 squared, the square root of 20 squared minus 12 squared. And notice we just get 16. So coming back to our to our actual problem. So what is the thing? Write your answer as a number. It is 16. And the second one says, so I'm just looking here. TV side is based on the length of its diagonal. So this is 17.1 and that's 10.4. So I can see that both of these, because that's the right angle, those are both legs. So if I come back to what I was doing on this screen, let me come back to this. I can see I have legs. So one of them was 17.2. Let me double check. 17.1 and 10.4. So 17.1 squared plus 10.4 squared, and I want the square root of that. So coming into the calculator, we have the square root of 17.1 squared. And because it's a leg, now I'm going to add them. Plus 10.4 squared, like this, right? And I get 20.01, so I'm going to just round. Let me see if I'm supposed to round. So I get either 20.1 or just 20. It says the whole number, so just 20. That would be a 20-inch screen, would have those measurements. Okay, so that is the end of Workbook 26.